Yeah, welcome back. Law of thermochemistry. There's something interesting in this topic. The interesting part of this topic is the conclusion of exothermic and endothermic. Thermochemistry signifies the difference between endochemistry and exochemistry. That is to say, it gives us the reaction whereby whenever the reaction is negative, it will tell us maybe it is what endochemistry, it is thermo, exo, it is what? It is known as what? Endothermic or exothermic. But let us have it at the back of our mind that whenever the reaction is negative, it is exothermic reaction. But if it is positive, it is what? Endothermic reaction. Let us have it that way. Now let us proceed quickly. We have law of thermochemistry. It's based on two first law of thermodynamics. The first law of thermodynamics is known as what? Lavoisier's and Laplace law. This man is a French man. So his law exists in the year 1780. He said that the heat absorbed is equal to the heat liberated when the reaction is reversed. The vice versa. Now, it's just like when we are looking at the sublimation reaction, when the solid is now being converted to what? To gas, and also conversion from gas to what? From conversion to solid. So you know that in that reaction, it is vice versa. The reaction is vice versa. So in this case, this tells us that the only difference between this vice versa is that the sublimation doesn't require maybe the reaction is negative or positive. So it never gives us what is now exothermic or endothermic. So now, when a thermochemistry equation is reversed, the sign of change in hydrogen or change in the heat is therefore change in hydrogen, that is forward, and change minus change in hydrogen, which is known as what? Backward. And that is when you are going to see this sign. So this sign indicates that the reaction is what? Is vice versa. So now, therefore, we now have energy, mass, mole relationship. The enthalpy change, which is change in hydrogen, is directly proportional to the amount in moles of the reactants or products. Now, calculation we have. Example, calculate the heat involved when 0.2 moles of carbon dioxide is formed from its elements. The molar heat of the formation of the carbon dioxide is given as minus 393 kilojoule per mole. If you now look at this now, provided it gives us negative, it is what? Exothermic. So therefore, we now have what? The equation of the reaction, which is what? Carbon plus oxygen, will give us what? Carbon dioxide, which is known as what? The change in reaction. Though I was about to what? To indicate the reaction terms to be like this. So then I can now say 1 mole of carbon dioxide liberated. It's liberated to 394 kilojoule of heat. Therefore, 0.2 moles of carbon dioxide will liberate to 394 times 0.2 kilojoule, which will now give us what? Which give us minus 78.6 kilojoule. That is, the reaction is what? Is exothermic reaction. Now, Example 2, this one is jam question. It says that we have hydrogen plus oxygen, 2 molecules of hydrogen and 2 molecules of oxygen. When they react together, they give us what? They give us 4 molecules of what? Water. That is to say, the exothermic reaction, which gives us what? Minus 571 kilojoule. In the equation above, how much heat will be liberated if 12 grams of hydrogen is burnt in excess of oxygen? That is burnt in excess in what? In oxygen. That is, if they expose it into what? Into oxygen like this. That is what? Burn in excess of what? Oxygen. Therefore, A, minus 571 kilojoule. B, minus 1142 kilojoule. C, minus 1713 kilojoule. D, plus 1142 kilojoule. That's the jam question. Now, let us now see. From the equation given to us, we have this equation here, which what? Water, and liberated to what? To the heat of what? Minus 571 kilojoule. Then we have 2 moles of this hydrogen here, 1 mole of what? Oxygen. So 2 moles of hydrogen give us what? 4.0 gram. 2 times 2, 4. 4.2 or 4.0 gram. 4.0 gram of hydrogen liberated to 571 kilojoule of heat. Therefore, we now have 12 gram of hydrogen liberated to what? To, remember, we have 4 gram here. Liberated to what? To 571 times 12 all over 4. If you use 4 to divide 12, we give you what? 3. 3 times this will give you what? Minus 1713 kilojoule. That is, it is what? Exothermic reaction. Can be reversed. Therefore, to now see, the answer is what? C. Are we there? Now, let us look at the second. Remember, we said the thermochemistry law based on 2 dynamic what? Laws. The second law of dynamic, which is known as what? Hale's law of constant heat summation. Hale's law of constant heat summation states that the heat of reaction is the same whether the reaction occurs in one or more steps. The heat of reaction is the same when what? Is the same whether the reaction occurs in one or more. If the reaction occurs in one element or in one compound or more compound, it is what? It is the same. Let us look at inference. 1. Its influence on what? Heat of reaction depends only on the initial reactants and the final products. It is dependent on the intermediate. 2. Thermochemical equation or data can be added together or subtracted as a algebraic equation. Example: calculate the heat of formation of carbon 2 oxide, given that the heat of the combustions of carbon and carbon 2 oxide are minus 393 kilojoule per mole and minus 285 kilojoule per mole respectively. That is why they say that what? Born on what? On 1 or more, because we are having what? 2. Are you with me? Then we can now say, given we have carbon plus oxygen, give us what? Carbon 4 oxide. Therefore, we now have what? The what? The change of what? Change in concentration. Change in concentration. We did that last class. Change in concentration and what? Change in what? Intensity of what? Of the heat. Now, the intensity of heat given to us minus 393 kilojoule per mole. Then we can now say the next one we have carbon dioxide plus half of the oxygen gas is liberated to what? Is liberated to carbon dioxide. Change in what? Change in concentration. Which now give us what? The change in what? Heat. That is equals to minus 285 kilojoule per mole. Required to find the carbon, a solid plus oxygen, half of oxygen give us carbon dioxide, change in what? Change in hydrogen. The energy cycle can be set up as follows. Here we have what? Carbon, a solid plus oxygen, which is in gas. Through heat, we now what? Through heat, it's what? It's melted and give us what? Carbon dioxide, which is what? Gas. You know, from a solid to gas, what formation is that? So sublimation. Yes or no? Through a sublimation. Now, if it now sublime, it can easily be reversed. That's why you see this arrow. That what? If it's sublime, if we now have out of oxygen, it now give us what? It will give us a gas and now converted back again to give us what? To give us a solid and back. That's what? Sublimation. That is, it goes and what? Come back. So therefore, we can now say from the energy cycle above, the energy heated plus what? Energy heated 1 is equal to what? Energy heated 2 plus energy heated 3. Therefore, make energy heated 2 the subject of the formula. Energy heated 2 is equal to energy heated 1 minus what? Energy heated 3. Therefore, we now have the what? The energy heated 1 is known as what? Minus 393 minus in brackets minus energy heated 3 minus 285 minus times minus plus. Let us subtract this from here. We now have what? 108 kilojoule per mole. So now, that is where we now have it in breaking down. We have carbon plus this. Give us what? Through the energy heated, it gives us what? This, as in the answer there. Then we can now say that what? Carbon dioxide of what? Half of the oxygen we now heat, which is now energy heated 3, to now give us this. That is, it comes out and through the sublime, it now what? It now forms from here. So I think that will be the end for today. If we have any question or addition or subtraction or anything at all, please and please let us indicate under the question, under the comments. My name still remains Ogunipe Saheed Oluwafemi. So I say, Nini Oluwa Ramilowo Bere.